The next section we're going to look at is Venn diagrams and set operations. This corresponds to section 2.3, and we're going to be looking at two sets first. So the first thing I want to say is these Venn diagrams are extraordinarily helpful in showing us what's going on with sets and set relationships. And in these Venn diagrams that we're going to see, we often have a rectangle that represents the universal set. The universal set, which is symbolized by a U, a capital letter U, is a set that contains all the elements for any specific discussion. So if I were to say days of the week, the set that contains the elements that are the days of the week, the universal set would be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then I could have a subset of the universal set of the days of the week that start with S's. The subsets of a universal set are often represented by circles. So you might have seen something that looks like this before. Okay? These circles are overlapping when they share elements of one another. But if they are disjoint and not overlapping, then they don't share any elements with one another. You could also have the situation where you could have a subset, a proper subset of a set within a universal set. So wrap our minds around that for a minute. So we have a lot of different possibilities. We could also have two sets that are exactly the same. So I'm going to show that they would overlap perfectly, which I'm going to try and do. Okay, so those are our four possibilities. They are disjoint and don't overlap at all. We have a proper subset, or they might overlap and share some elements, or they might be exactly the same sets. So that's just a visual representation of what could possibly happen within this universal set. So let's jump right into some definitions. First one that we're going to look at is the complement. And the complement of a set is all the elements in the universal set, but they're not in the set we're looking at. So if I'm talking about the set A, complement, which we mark with a little apostrophe, it's going to be the set of all elements in U that are not in A. So, in this little diagram I just drew, we have the set A, which contains 3 and 4. The universal set contains 1, 2, 3, and 4. And if I were to say what is the complement of A, the complement of A would be 1 and 2. So in this example, A is equal to 3 and 4, and the complement of A is equal to 1 and 2. We can also have this diagram here where we show the shaded in red represents A, and the shaded in purple represents a complement. So it's everything in the universal set aside from the elements in set A. The intersection of two sets we would write as A intersection B are all the elements that are common to both A and B. I always like to think of this as these are the elements that must be in both sets to be counted. In a Venn diagram, I'm going to shade this in blue. They're represented by the elements that show up in both of the sets. So if this set was A from that circle and this set was B from this circle, the intersection, which uses this symbol here, I'm going to circle that in blue, it is the elements that are common to both, so they're the elements that are shared in between the overlapping part of both circles. The union of two sets, represented by this symbol, which I'll circle in blue, okay, is all the elements that are members of either A or B. So all elements in A or B. If we were to draw this out as a diagram, a Venn diagram, and here I have this circle represents all the items in A, and this one represents all the elements in B. The intersection is the elements in this entire Venn diagram, even including the one shared by both. So I always think of the intersection as being our and. It has to be in A and in B to count. And the union I always think of as being in or. I count it and count it in the union if the element shows up in either A or B or both. Okay? So intersections and, unions or. One more time, intersections and, unions or. The intersection slices out everything that's not included in both of them. But the union, which is kind of a nice word for it, includes everything that's in both. Kind of like the union of people. You can think of maybe the United States. It's the union formed together, okay? So there's different ways to think about it, but you want to make sure you remember each one. Another important definition is set differences. And when you think of this as the difference of two sets, we can symbolize it as A minus B. Okay? It's a set of elements that belong to set A but not to set B. So if I were to draw a Venn diagram, and let's say I had A and B, and A contains 1, 2, 3, and they both contain 4, and B contains 5 and 6, then the difference A minus B, or the difference between A and B, would be the set containing 1, 2, 3. It's everything that belongs to A but not B, so I can't include 4 because it's shared by both. So let's try these out with this first example. We have the universal set, which contains every number within all of the entire rectangle. So that purple rectangle contains 2, 4, 5, 6, 7, and 8. So if I were to write that in roster form, the universal set contains 2, 4, 5, 6, 7, and 8. All the numbers in the rectangle are counted in the universal set, even these ones outside, okay? Now the set A contains the values 2 and 4. It's everything within this red circle. The set B is everything in the blue circle. So that's going to be 4, 5, and 7. Now we want to think about what's in A complement. A complement is everything in the universal set that's not in A, okay? So everything in the universal set but is not in A. So it's pretty much like we're blocking out, I'm going to do this, we're blocking out A and counting everything that's left. That's how we get A complement. So what's left would be 5, 6, 7, and 8. Okay, now let me actually go back just because I didn't want to have that A blocked out anymore. And we're going to do the same thing for B complement. So the complement of B is everything in the universal set except for what's in B. So if I cross out B, what's left? We have 2, 6, and 8. And that's how we find our complements. Now, looking at the same set, we're going to find our intersection, our union, our difference between A and B, and the difference between B and A. So the intersection, remember, that's the space where they are overlapping. We only count the elements if they are both in A and in B. So the intersection of A and B is the set containing 4. The union of A and B is everything that I'm outlining right now in purple. It's everything contained in A or in B. So that's going to be the set that contains 2, 4, 5, and 7. For the difference of A and B, we're going to take A, which has 2 and 4, and subtract anything that's also in B. So if I think about this, I'm going to look at my set that's A and my set that's B, and anything that's in both, I get rid of. So that just leaves me with 2. Going the other way around, B subtract my A, or the difference between B and A. If I have A as 2 and 4, I'm going to remove the thing that they share in common. So what's left is 5 and 7. We have another example here. Again, the universal set is all the numbers within the rectangular box. So the universal set's going to contain the elements 1, 2, 3, 4, 5, 6, 7, and 8. The set A contains everything in that red circle. So that's going to be 3, 4, 5, and 6. B is going to be everything contained in the blue circle. So that's going to be 5, 6, 7, and 8. Again, the order doesn't matter. I could have written 7, 8, 5, 6. It doesn't matter as long as you contain all of the elements in your set. The complement of A is everything that's outside of the red circle. So the complement of A is going to be 1, 2, 7, and 8 because it's everything in the purple box except what's in the red circle. And the complement of B is going to be everything that's in the universal purple box except what's in the blue circle. So I have the complement of B being 1, 2, 3, and 4. So we have our universal set. We have set A, we have set B, we have the complements of A and B. So now we're going to find what's the intersection, what's the set of the intersection of A and B. Remember that upside down U is the intersection, and that's what elements are shared and overlapped in both circles. So the intersection of A and B is going to be the elements 5 and 6, and the union of A and B is going to be everything that's within both the circles for A and B, okay? So that's going to be 3, 4, 5, 6, 7, and 8. I kind of ran out of room there, okay? Now if I were to do A, the difference of A and B, that would be A, take away anything that's in B. So it's A, take away the intersection pieces. So 3, 4, 5, 6, take away elements 5 and 6, we're left with 3 and 4. B, the difference between B and A, or the difference of B and A, is everything in B, take away what's shared in A. Okay, so that's going to be 5, 6, 7, 8, subtract or take away the intersection 5 and 6. So that just leaves us with 7, 8. So a quick recap is the intersection is our and. It's what's in both. What's shared in both. Versus the union, which is the or, we count if it's in either or either set. So you could think of this as all elements in both sets, including what's shared. The complement is essentially the universal set minus A, if we're talking about the complement of A. And the set difference is the set A take away what's in B. Again, the set difference is the elements of A that are not in B. So you only count the things that are purely only in set A. Okay? The complement is everything in the universal set except everything that's in set A. All right? So this is another way you could think about the complement. Now it's going to get a little tricky because we're going to look at the intersections and unions and include and involve sets complements. So in this example, we're told that the universal set is the set of natural numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're told that the set of A is the set containing the elements 2, 3, 4, 5, 6, and set B is the set containing elements 4, 5, 6, 7, and 8. So one thing we might want to do is on the side over here, we might want to write down what is A complement and what is the complement of B. So the complement of A is everything in the universal set that's not in A. So that's going to be 1, 7, 8, 9, 10. So it's a set containing 1, 7, 8, 9, 10. And the complement of B is going to be 1, 2, 3, 9, and 10. Just because we see that we're going to need those complements for here. So that's a good best practice, is the second you see you're going to need a set's complement, you should write out what that complement is. So for this first example, which I'm going to outline in blue, we're looking at the complement of A intersected with the set B. So what's in both A complement and B? So if I look at A complement, that's 1, 7, 8, 9, 10, and B contains 4, 5, 6, 7, and 8. So I'm looking for the things that are in both. So B and A complement both have the values 7 and 8. So we can only count the elements that are in both A complement and set B. So that is 7 and 8. Now we're going to look at the complement of the union of A and B. So the union of A and B is going to be everything that is in A and everything that is in B. So let's take a second and actually draw out the Venn diagram that matches this information. So we have the universal set, we have set A, we have set B. Set A contains 2, 3, 4, 5, and 6, and B contains the elements 4, 5, 6, 7, and 8. So they both share 4, 5, and 6. Okay? And so then A also contains 2 and 3, and B also contains 7 and 8, but those are not shared across both sets. And then the remaining values that are in the universal set that weren't in A and B are 1, 9, and 10. Okay, so if we're looking at the complement of the union of A and B, we're looking for everything in the universal set that's not in the union of A and B. So we're looking at, if I block out the union of A and B, what's left in the universal set? And so that is the set containing 1, 9, and 10. Okay? Now for this one, we're looking at the intersection of A and B. That's what's contained in the overlap. What's in A and B is in 4, 5, and are the elements 4, 5, and 6. And we want the complement of that. So we want everything that's in the universal set except for 4, 5, and 6. So that leaves us with 1, 2, 3, 7, 8, 9, and 10. Let me write that better. 9 and 10. Okay, so be very careful with these. Make sure you understand, is the complement applying to the set, or is it applying to the intersection of the set, or is it applying to the union of the set? Now we're going to look at A minus B complement, or the set difference between A and B complement. Well, B complement is everything in the universal set that's not in the set B. Okay, so we wrote B complement here. That's 1, 2, 3, 9, and 10. And so what we're going to do is we're going to take the set A, which we have up top, and we're going to remove everything that's in B complement. So if it's in B complement, we're going to remove it. So B complement has 1, 2, so we're going to remove 2. It has 3, so we're going to remove 3, and it has 9, and it has 10. So then what's left in the set A? That's going to be 4, 5, and 6. We can see that here. I know this video is getting really long, but we have just 2 more to go through with this example, and then the next video should be a lot shorter because it covers a lot less. The investigation and everything else will just be posted on blackboards for you to look at or to try on your own and then check your work. So I promise the next video will be shorter. This one's like one of the longest ones we'll probably have, hopefully, ever. But we still have to look at 2 more things. We have the union of A complement and B complement. So that's everything that's in A complement and in B complement. So that includes the values 1, because that's in both, 2, 3. The next one is 7, 8, 9s in both, we include that, and 10. So we find everything that's in A complement, everything that's in B complement, and include each of those elements. If it's in both, it still gets counted, okay? So the union is everything that's within those complements. The last one we have for this example is we're looking at the set difference between A and B, but it's complement. So what we're going to do, this follows order of operations. We want to do whatever is in parentheses first, just like order of operations tells us to do parentheses and exponents, multiplication and division at the same time, and addition and subtraction at the same time. Just like we start with parentheses in our order of operations, we're going to start with our parentheses here. So we first need to do the set difference first. So if I take A and I subtract B, what's left? That's just the values 2 and 3, right? But I now need to do the complement of that. So the complement of that set difference is everything in the universal set that's not those 2 elements. So that's going to be the elements 1, 4, 5, 6, 7, 8, 9, 10. So that is the last example, or last part of that example. I'm going to continue part 2 with the Cartesian products and a couple of extensions. But again, the challenge and the investigation will be done on your own, and then you can check your work with what I post on Blackboard. So I promise the next one will be a lot shorter. Thank you.